Hello everyone, this is Professor Wei here. In this video, I want to show you how to work on regressions, ordinary least square regressions using Microsoft Excel. Okay, so this is the one of the examples we went over in class. If you were not there, for whatever reasons, this is a great opportunity for you to catch up. Okay, so for first, let me share my screen. So on your canvas, I posted a file under your learning module. I think it's, let me see, it's chapter X, regression estimation. Okay, so we're going to work on or revisit one of our in-class examples, in-class exercise question on OLS regression estimation. Okay, now, so as I mentioned in class, regression is extremely useful whenever it comes to the case where you want to explore the association between two variables or multiple variables you are interested. Okay, so for example, in the example, let's say the example I give you in a class, if I want to, explore the association between student performance and the size of the class, then you need to find the data and then run some sort of a correlation or regression analysis to find out the sensitivity, the coefficient. Now here we want to do it in a more rigorous way, and that is using some basic applied statistics methods to explore the association between the real estate housing price and the inventory, as well as the labor force participation measured by the data from Federal Reserve Data Center, which is a public data source commonly used by finance and economics practitioners, as well as people in academics. Okay, so make sure you go to the canvas, download the instruction, and we are going to work on the question. Okay, so first thing first, we want to make sure we have access to all the data. Okay, so of course, the Federal Reserve Data Center is public data. There are many other form of data platforms. So each data has a unique identifier, similar with the notion of a stock ticker. Okay, in this case, it's just a variable name. So we are going to use the active listing count in the US economy as the proxy of housing price data, the average level. Okay, and also we have, the listing count is going to be the proxy for the inventory, the number of the available houses on the market. And also we have the variable named as medium listing price in the US. Okay, that's going to be the proxy for the listing price or the housing price level. Okay, the number of all employees in the construction sector, and that's the measurement of the labor. Okay, of course, your intuition may tell you the price might be directly or indirectly affected by or determined by the inventory as well as the labor for obvious reasons. But now the issue is to what extent? What's going to be the economic magnitude? Okay, that's the question we are going to solve for. Okay, so now first, let's download all the data. And so, of course, we have to go to the Federal Reserve Data Center, then copy the variable name. Let's download the medium listing price in the first place. As you can see, it's housing inventory, median listing price. Okay, now one thing you want to pay attention is the fact that for each one of the variables on these platforms, as well as any other platforms, is the frequency. Okay, some data are daily frequency, some are monthly, some are quarter or annual. You never know. Okay, so in this case, it's monthly data. It means that each data point represent data the frequency is at the monthly level. Okay, so we are going to download the past 5-year housing inventory data. Okay, so let's do download. Make sure you select the CSV. Okay, now that's how you download the first variable, and you do that for the active listing count. 5-year window, download, CSV. And the last one is going to be the number of all employees in the construction sector. All right. Again, you make sure you select the 5-year window. Okay. Now, on your local download folder, you should have 3 separate CSV files. Okay. Make sure you create a separate XLS Excel spreadsheet. And let's save it as OLS example housing price. Okay. I'm going to save it to my local desktop folder. You can save the file to any, working environment you're comfortable with. Okay, so now let's put the data all together. All right, so this is the medium listing price. Let's rename the variable to be the price. Okay, and the second data we are going to copy over will be the listing count. And let's call it inventory. Okay. And the third would be the labor. Let's copy over. Okay. Let's reformat a little bit. Recenter everything. And let's rename the first column to be the date. So, this data or these 3 data sources are pretty clean. Okay, so basically you have variables over the same time frame with exactly identical frequency. So you don't need to worry about the frequency reduction or any form of data processing to convert let's say the daily frequency data to monthly to annual or reduce to the frequency. Okay, so naturally you can just copy them all together because the frequency are pretty much exactly identical. All right, so now what we want to do is to use the inventory and the labor to explain the price. Okay, in the regression analysis, okay, we can implement something called a univariate analysis. So basically, you are using one single X to explain your outcome variable or dependent variable price. Okay, you can also run multivariate analysis. So you're using more than one variables to explain your dependent variable. Okay, just a quick review. Your y would be the dependent variable in your regression analysis. Your x would be your independent variable. Okay, or explanatory variable is your x. Your y would be explained variable. Okay, and the coefficient on the independent variable, usually termed as beta. Okay. And you also have the mu, call it a residual. Okay. So your y is explained by your beta times x plus the residual mu plus the intercept alpha. Okay, and the beta is your sensitivity. If you have multivariate, structure, you have beta x1 plus beta x2. Okay, so you really need to sum them up. Okay, all right. So let's work on the exercise using Excel. So once you load the Excel, I think it's called Excel adding, you have this data analysis tab button under the data tab. Okay, so what we want to do is to run the regression. Let's run a univariate regression in the first place. So in this, window, you can see you're asked to specify the range of your y and the range of your x. Okay, so in this case, we're going to explain your housing price as a dependent variable. So we want to choose y as your price. Okay, let's select the price, including the first row, which is a label or the variable name. Okay, so make sure you go back to the window and select your x, and let's do labor. Okay, you have your label checked. By checking this label button, you're indicating Excel that the first row will be the label or the variable name. Okay, it will not be engaging any form of computation. And also you want to check the OLS line fit plots so that you can see the linear trend. Okay, once you're ready, click on OK. All right. Okay, so let's format everything a little bit. Insert a predicted price. Yeah, something like that. Okay, so the idea is that in this two-dimensional space, we find out a linear trend that can well capture the association between the housing price and the labor supply by gauging the magnitude of the price response with respect to the labor participation. Okay, so in other words, if you look at the regression output, what we do care about is the R square, in this case, is 69%, and the observation is 61 because it's monthly data over 5 years. All right, so that's basically around 60 months. Okay, so the idea is that 69%, which is the R square, 69% of a variation in price can be explained by your independent variable, labor. Okay, 1 unit change in the labor leads to 79%, 79 unit change in the housing price, and the T-stat is highly significant. It's 11, way beyond the critical value. Okay, so this is the univariate regression. We can also run multivariate. Basically, we're using two variables to jointly explain the housing price. To do that, we can go back to the data analysis, regression, and reselect your X range being both inventory and the labor. Okay, then you check OK. You can see in this case, you got two results, two results on the coefficients, right? So your labor is positive, whereas the inventory is negative. Okay, and each one of them is associated with a set of statistics. We do care about the coefficient magnitude as well as the statistical significance. Okay, and R square here in this case is 70%. All right. Now, in general, one thing I want to comment is the fact that most of the time, we do not run regression whenever the magnitude of the data is quite different. We want to normalize the data. Okay, to do that, we can actually transform the data by taking the natural log of each one of them. Oops. Let's call the transformed price being log price. And we also have log inventory, as well as the log labor. Okay, all we need to do is to take the natural log, all of them. Let's keep the just two decimals to be readable. Okay, so you can highlight these three numbers when you place your trackpad or your mouse to the this bottom corner, or right bottom corner. You can see there's a little cross. When you double click, Excel will automatically load all the formulas. Okay, now you can see the magnitude is much more consistent across these three variables. Okay, so for computation purpose, we can, transform the data and rerun the data analysis regression, and we want to reselect the Y range being the log price and log X inventory and the labor jointly. Okay, now check the line fade plots, and you run the regression. Okay, now it's much more readable. Okay, all right. So similarly, the log price will be negatively predicted by the log inventory, but positively predicted by the log labor. All right. Again, both measurements are statistically significant. The coefficients on log inventory is negative 0.505 and positive 1.6 on the log labor. So 1 unit change in the labor in the labor participation will lead to 1.6 unit change in the outcome variable measured by the log housing price. Okay, so this is actually a very useful and implementable methodologies in mostly social science whenever we want to measure the dynamic between two variables, right? So in the next lecture, we are going to use this method to explore the dynamic between the market risk premium and the stock return. Okay, you will find out the coefficient on the market risk premium is nothing more than the stock beta. Okay, so that's something I plan to cover in the next lecture. Okay, all right, I'll see you guys in class.